Hello everyone, welcome to my YouTube channel. My name is Bhumika, pursuing the degree of Electronics and Communication Engineering in Sri Venkateswara College of Engineering, Bangalore. Today's video is about the subject microcontroller. In microcontroller, we are going to talk about the topic call instruction and how it is used for subroutine calls, including the role of stack in subroutine calls. Well, first coming to the concept of subroutine. A subprogram that can be used any number of lines by the main program. When the same function is required more than once in a program, it is frequently written as a subroutine. As you can see in the diagram, the subroutine allows a program to break down the complete task into smaller, more manageable places. A subroutine is a block of code that can be called from anywhere in the program and then returns control back to calling code when it is done. The stack state in the figure corresponds to the time at which the processor executes instruction within the second subroutine. As in the shown figure, the stack is used for the register savings in a subroutine. The recovery should LIFO fashion, otherwise the return address cannot be recovered properly into the programming control. The next topic is nested subroutine. As there are three parallel subroutines, namely 1, 2 and 3, which are linked to the return address of subroutine 1 with a link register. The subroutine nesting is common programming practice in which entire subroutine calls another subroutine. When subroutine 1 calls subroutine 2, the return address of subroutine 2 should be saved somewhere. So if the link register stores the return address of any subroutine 1, this will be destroyed or overwritten by the return address of subroutine 2. The stack data of the structure is the most efficient way to store the return address of the subroutine, as the subroutine isn't called a first one of the returned or the last in first out of the format. As you can see, the types of subroutine where the instruction for subroutine in 8051 are given by a call and a return, where in call the instruction is used to call a subroutine, the current program counter where the PC is pushed into the stack, and then the program counter is set to the address of the first instruction in the subroutine. The return instruction is used to return from a subroutine. The topmost item of a stack is popped into the program counter, which restores the original program counter and continues execution of the calling code. As you can see, the instruction for subroutine in 8051 have four different types description, where the first one is absolute subroutine call, and the second one is the longest subroutine call, and the third one is return from subroutine, and the last one is return from interpret subroutine. And you can see the each mnemonic has a byte and a cycle. The instruction for subroutines in 8051, where the first one is lcall address, where the instruction is used to call a subroutine and the current program counter is pushed onto the stack, and then the program counter is set to the address of the first instruction in the subroutine. The second one is acall address. The program is loaded with the indicated address. This subroutine address is to be loaded in the PC to calculate by replacing LSB of the program counter with the lower byte of absolute address scientific in the acall and replacing the bits of 0 to 2 to the MSB of the program with upper 3 bits of the 11 bits address. The bit from 3 to 7 of MSB of the counter remains unchanged. The next one is return. This instruction is used to return from a subroutine where the program execution continues from the address that is stored on the stock by lcall or acall instruction. As a result, this returns the address in calling program. There are no flags that are affected in this return program. Thank you. I hope this video was interesting and useful to you all. Let us meet with an interesting topic in the next video. Thank you. Have a nice day.